Let us discuss a problem of JEE Advanced Physics 2011. This is based on energy balance, and it also uses the property of spring force and friction. Problem is this, that there is a block of mass m whose value is known, say 0.18 kg. It is placed on a rough horizontal floor. The floor has friction coefficient, and in fact kinetic friction coefficient 0.1 with respect to this block, and there is a spring constant 2 Newton per meter. A spring one end fixed, other end is connected to this block. When the spring is undeformed or unstressed, from that situation, this block is given certain velocity through an impulse. That velocity is not known. But after the velocity is given to this block, the block moves by distance. Block slides a distance 0.06 meter and comes to rest for the first time. यानी block 0.06 मीटर चल के पहली बार रुक जाता है. तो विद दैट इंफॉर्मेशन हमें बताना है कि इनिशियल वेलोसिटी को अगर लिखा जाए n/10, इफ द इनिशियल वेलोसिटी इज रिटन एज n/10, then find the value of n which is going to be an integer, right? So it is simple problem, but you need to do some calculations and apply the energy balance properly. Initially we are giving a kinetic energy into system, and when this block moves, the kinetic energy is partially converted into potential energy of a spring, because the spring will be deformed, and since there is friction to oppose its motion, there will be work against friction. In fact, that work will appear as heat. So initial kinetic energy given should be equal to potential energy of the spring and work against friction, because finally it is stopping, so there is no kinetic energy left. So all kinetic energy will be used to work against friction, as well as partly it will be used to work against friction, and partly it will be converted into spring's potential energy. So this equation is written here. Initial velocity if taken as v, then half v square is vmgx plus half x square. This is work against friction. This is energy stored in the spring. Value of every quantity is given except v. X is given as 0.06, mu is 0.1, k is 2, all in SI units. So if we substitute, we will get v as 0.4. And there is no tough calculation, it is simple calculation. And this can be written as 4/10. So if we compare it from the question, n/10 and 4/10, then clearly n is 4. But in future there may be 2 more questions on the same problem, and those questions are very interesting. The question may be, after this block stops, analyze whether it will start coming back or not, and also find the friction force after the block stops. So you try, and then I am going to explain the solution. So let us discuss the solution. After the block stops, for a moment, assume that there is no friction for a moment. From this side, there is friction, spring force, that is kx, and this kx value will be equal to 2 into 0.06, that is 0.12 Newton. And since at this time velocity is 0 and spring force is cannot change suddenly, but friction can adjust its value within no time. So what friction will do? Friction will observe that if it does not act, the spring force will bring the block in backward direction. And since there is no velocity, spring force will be able to move this block in the left. Then friction will become active and it will start acting in the right direction. And will try to avoid the motion of the block. For that purpose, friction should be only 0.12. Let us check the maximum value of friction which it can act. Maximum friction is mu mg. Mu is 0.1, mg is m is 0.18 and g is 10. It is going to come 0.18. 0.18 is the maximum friction. Required friction is kx, that is 0.12 Newton. So friction is having more capacity than it required. The friction will act actually equal to 0.12 Newton. Friction force will be only 0.12 Newton and it will keep the block at rest. And one thing more interesting, when it was moving in the right direction before stopping, friction was acting in the left direction. But after it stops, now it has to act in right direction. So after the block stops, friction suddenly reverses its direction from left to right and also changes its value, because initially its value was total maximum value, that is 0.18, because there was motion. Friction will act with full value to oppose the motion. So after it stops, there are changes in the direction of friction as well as in its magnitude. That is the interesting result.